Oh, hey guys, how we doing today? All right, this is the last part in topic one, chapter one, I guess. I don't know. The last section of topic one is probably how it's supposed to go. It's Monday, it's early. Okay. Today, guys, we were talking about operations with scientific notation. So, addition, subtraction, multiplication, and division. Man, I need a haircut. So yeah, that's the idea here today. So the homecoming committee wants to fly an aerial banner over the football game. The banner is about 1,280 inches long and 780 inches tall. How many different ways can the banner be expressed? I'm just going to show you one, I guess, maybe two. We'll see. So if we want to find the area, right, we're going to take that, right? Remember, area of a rectangle is base times height. Right. I don't know why I capitalized the B but not the H. I don't know. So it's 1280 by 780, right? I'll probably use the dot, that's fine. So I'm just going to use a calculator for that because, I mean, yeah, I don't want to do that in my head. 1280 by 780, so 998,400. So 998,400. So the area is 998,400. Square feet. Square inches, actually. Inches squared. Man, it's early, guys. Sorry. Off my game today. So yeah, and then we can take this, we can convert it into scientific notation. Your decimal's right here, so we want to move it basically between that 9 and 9. So we go 1, 2, 3, 4, 5. So we say 9.984 times 10 to the fifth. Right? We've been doing scientific notation, kind of just a little review of how to do that. Another way to show it is you can actually convert it into scientific notation before you have to worry about that, right? Before you do it. So we can take that 1280, we move it over 3 times. So we have 1.28 times 10 cubed, and then move it over. So we have times 7.8 times 10 squared. Because we moved it over twice, that decimal 1, 2, right? So then we have these two, which we can actually kind of put these together. Like we can be like 1.28 times 7.8, and then we can multiply that by the exponents. 10 cubed times 10 squared. And then I'll just use the 1.28 times 7.8. And oh, look at that, 9.984, which is exactly what we had. And then when we multiply exponential expressions with the same base and different exponents, you keep the base and add your exponents. So times 10 to the fifth. I should actually put units on these as well. So yeah, kind of two different ways to get there. And this is what we're going to be exploring today, is kind of that second way of how to do that. Yeah, there's your intro there, guys. Okay. Add or subtract numbers in scientific notation. How much greater is the mass of the Earth than that of the Moon? What does the exponent tell you about the magnitude of the number? So this is going to be a subtraction problem. What am I looking for here? Let me pause one sec, guys. Sorry. I'm not going to edit this out, so you'll just have to deal with the pause. Sorry. Got to pause again here. Back again. Sorry, the printer issue. I have to take care of it. Okay. So add or subtract numbers in scientific notation. I mean, it's only going to be one example. This is going to be a subtraction example, but otherwise you would just add it, right? I mean, okay. So how much greater is the mass of the Earth than that of the Moon? What does the exponent tell you about the magnitude of the number? So the basic idea here is we're going to take the mass of the Earth. I'm going to say mass of Earth, and we're going to subtract the mass of the Moon. That's the basic idea here, okay? And then that's going to tell us like how much greater it is, right? How much bigger the Earth is than the moon, right? So we have the mass of the Earth right here, 5.97 times 10 to the 24th, and the mass of the moon is 7.35 times 10 to the 22nd. So that 10 to the 24th means there's going to be 22 zeros, that 9, 7, and then 22 extra zeros on top of that because you have 24 spaces, right? So let's do it, right? 9, 7, and then 22. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. That's a lot of zeros. I would recommend writing small here, and then to help yourself organize it, give commas every 3. So I don't know. I don't even know what that number is, right? Let's see: thousands, millions, billions, trillions, quadrillions, quintillions, sextrillions. 597 septillion tons, kilograms. Yeah. Okay. So then this is going to be 22 minus those, so 20. 20 zeros. I'm actually going to start this way so I can line them up better. So this is the mass of the moon. So I need 20 zeros, right? Yeah, okay. There's 22 spaces, but 2 of those spaces are already taken by that 3 and that 5. So then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then let's double check. I've got my... Let's see, 3, 6, 9, 12, 15, 18, 20. Perfect. And then 5, 3, 7. This is a pain in the butt, huh? All right. So let's see. I'm just going to do this like I'm just going to line it up here. So we got a 0, 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 because 0 minus 0 is just 0, right? And then 10 minus 5 is 5. We took it there, so 9. So 9 minus 3 is 6. Put a 0 in there. And then 10 minus 7 is 3. That's a 9. And then 7, 9, 5. No, because we had to borrow from there, so that's a 6. So 6 right there. That's a lot, right? Let me double check I got my numbers right there. 5.896? Oh, did I screw up here somewhere? Yeah, anyway, it's still 24 spaces. It's definitely less. Anyway, you can see that that's kind of difficult, right? Yeah, because I think I screwed it up because the book says it should be like 5, 8. Anyway, you could see like you and I screwed up, right? That's a pain in the butt to work with. So let's make it a little bit easier. So what we're going to do is we're going to basically just subtract it in scientific notation. But to do that, we have to have the same exponent, right? So if we take this 5.97 times 10 to the 24th, we can actually shift our decimal a little bit and adjust our exponent, right? So if we actually take this 597 and shift it over here, 2 spaces, that means we take 2 off of that decimal space, right? So it becomes 597 times 10 to the 22nd, right? Because we're looking for that 10 to 22nd. We're looking for the exponents to match. And that's the idea here, guys. Because this way, you match your exponents up and then you can subtract them, and it is much, much easier to deal with, right? It's not technically in scientific notation at that point because the decimal's not, in between the 5 and the 9. But we're kind of just like actually doing the work here. So it doesn't matter for right now that it's not in scientific notation. So then we subtract 7.35 times 10 to to the 22nd. Yeah, and then we subtract. 1 second here. Oh, well, I know what I'm doing here. I know what I'm doing wrong. Yeah, because I was like, that's not going to work out. So the idea here is that you're going to say, sorry, we're going to kind of like change that. It's 597 times 10 to the 22nd, right? Minus 7.35 times 10 to the 22nd. And we can adjust it a little bit because we can take that kind of 10 to the 22nd out, right? Because you're multiplying both of them by that 10 to the 22nd. So then you can kind of go 597 minus 7.35 and then times 10 to the 22nd. That way we don't cancel those out. Yeah. Okay, so then we'll just use a calculator for that. At 597 minus 7.35 gets us to, 589.65 times 10 to the 22nd. And now we want to convert this into scientific notation. So we move our decimal point 2 spots, and that makes that go up to the 24th, right? So it becomes 5.8965 times 10 to the 24th kilograms. And that right there, friends, is our answer. So yeah, that's how much bigger the Earth is than the Moon. Is, almost 6 billion. That's basically to say that the Moon is not very big compared to the Earth. Yeah, that's that. That's kind of how you subtract it. It's a lot easier here than it is here, right? When you're adding or subtracting, you basically convert them so it's they're both have the same exponent. You just do that by shifting your decimals, right? We took that 597 by 0.97, we shifted it twice to 597, and that made the exponents go down 2 spots, right? And then we were able to get that same exponent right there. Yeah, and then you subtract your kind of the decimals or the digits out front, and that's that. Okay. All right. So this one right here, try this on your own, come back. We have the planet Venus is on average 2.5 times 10 to the 7th kilometers from Earth. The planet Mars is on average 2.25 times 10 to the 8th kilometers from Earth. What is the average distance from Venus to Mars? So you basically just subtract them right there, right? But you want to convert them to so the same decimal first, right? So we're going to take that 2.25 times 10 to the 8th. We want to get a decimal of 7, so we move it over by 1. Boom, right there. So it becomes 22.5 times 10 to the 8th, and now we subtract them. So yeah, it's 22.5 times 10 to the 8th. Sorry, 7th. My bad. I totally shifted and then forgot it. And then we're subtracting 2.5 times 10 to the 7th. And so we can just take the numbers out front and subtract them, and then multiply the result by that 10 to the 7th. So then 22.5 minus 2.5 is 20. Oh, that's easy. 20 times 10 to the 7th, and then we want to move it. Boom. And that makes that go up, right? So 2 times 10 to the 8th. Yeah, like so. Sorry. Once you move it over, and the exponent goes up. Yes, so 2 times 10 to the 8th on that one. Yeah. So it's basically, that's the difference. The average distance from Venus to Mars is the difference between the difference from Earth for each of them. Yeah. Okay, now we're going to multiply numbers in scientific notation. The Confederation Bridge connects New Brunswick to Prince Edward Island. The main part of the bridge rests on piers that form 43 segments. What is the approximate length of the main part of the bridge? Express your answer in scientific notation. And this one is actually super similar to the solve and discuss it we have on the first page right there. So we have this 8.2 times 10 squared, and we're going to multiply it by 43. Right, but 43 is not in scientific notation. So what we're going to do is shift that decimal point over 1, and that gives us 4.3 times 10 to the first. Right? And then now we'll multiply them together. We take the numbers out front, that 8.2 and that 4.3. We multiply those two, and then we multiply our 10 squared times 10 to the first, just like that. And then, yeah, what's that? 8.2 times 4.3. I think the multiplication is actually probably easiest. 35.26. Right? And then we have our product rule happening. So we get 10 cubed, right? Remember, when it's the same base, different exponents, and you multiply them, you just add your exponents. So 35.26 times 10 cubed. We shift our decimal over, and we get 3.526 times 10 to the fourth feet. Yep. So what's the approximate length of the main part of the bridge? You just multiply that times 43, and that's it, right? So this is, 3.526 times 10 to the fourth, which is like 35,000 feet. Is that right? 7 miles? You just double check my math here. So 8.2 times 10 squared is 820. Yep, and then times 43. Yeah, 35,000 feet long. Wow. Okay. A queen ant, but that's a lot of eggs. Good God. 1.83 times 10 to the sixth eggs over a period of 30 days. That's pretty gross. Assuming she lays the same number of eggs each day, about how many eggs does she lay in one day? So the idea here is we're going to take this 183.10 times 10 to the sixth and divide by 30 to get how much she lays in one day. So we're going to take that 30, convert it into scientific notation. We move it over 1, the decimal, and we get 3 times 10 to the first. And now we're going to kind of like match these up, match the numbers out front. We're going to say 1.83 divided by 3 times 10 to the sixth divided by 10 to the first. 1.83 divided by 3. I don't really want to do that by hand. So it gets us 0.61. Right? And then we're multiplying by this. So when you are dividing exponential expressions with the same base and different exponents, you subtract, right? So that's 10 to the fifth. 6 minus 1 is 5. Okay, now we are shifting it to the right to get it into scientific notation. So that becomes 6.1 times 10 to the fourth, right? Because when you're going to the right, your exponents go down. When you're going to the left, your exponents go up, right? And so that's 6.1 times 10 to the fourth eggs in one day. Gross. Yeah, that's like 60,000. Let's double check here. 6.1 times 10 to the fourth. Yeah, 61,000 eggs in a day. Whoa, that's so many gross ant eggs. Okay, so we're gonna take this, fold it in half, hamburger style, right? Put it in our notebooks. This is gonna go on page 17. Fold it in half like so, right? Make sure the white blank part is on the back. That's where the glue goes. Okay. This is going to go on page 17. This is operations with scientific notation. Just like so. So yeah, that's what it'll look like in your notebook. Let me take a picture of that actually. Zoot. And then page 17 in your table of contents, 1-10, operations with scientific notation. Picture of that. You can see it. Okay. There you go, guys. Thanks.